Helium, that noble gas you remember hearing about in your high school science class, not in terms of royalty, but in terms of the fact that it doesn't react chemically with other elements, because, according to high school, it has a full outer shell, and according to college, it has 2 valence electrons, thereby satisfying the duet rule that just a few elements abide by. Oh yeah, it's also the stuff you put in party balloons, so they float in the air instead of falling to the ground, like if you'd used the good old huff and puff method to blow up said balloons. But here's the thing, stop buying helium balloons. It may cost you $1 or $2 for the privilege of having a floating balloon, but to a scientist, the worth is more like $100. The issue is that helium is a non-renewable resource. We can't make it. We can only find it trapped in the Earth. Once it's in the atmosphere, it's lost to space. In fact, about 1,600 tons of helium is lost to space each year. When you consider how light helium is, you realize that's a lot of helium. Where did it come from? The radioactive decay of elements such as uranium and thorium in the Earth's crust. Upon its formation, the helium rises towards the surface of the planet, but can become trapped in impermeable rocks and shallow gas fields, the same reservoirs that trap natural gas. When the gas from these fields is processed, the helium can be extracted. However, we're using it faster than the Earth can make it. The radioactive decay mentioned before is a slow process. Some estimates have us running out of helium in 25 to 30 years. The British Medical Association even went so far as to call for a worldwide ban on helium-filled party balloons. So what's the biggie? No more party balloons? Well, there's that. But what else do we use helium for? Let's see. Medical devices such as MRI scanners, for one. Superconducting magnets, like those of the Large Hadron Collider. Welding, weather balloons, cooling rockets. The list goes on. Wait, did I say MRI scanners? I sure did. About 2,000 litres of liquid helium is needed per MRI scanner. This is because as a liquid, it's actually the coolest element on Earth. It's pumped through the magnets of an MRI machine to keep their superconductivity and keep the machine running. So yeah, a much more important use than helium balloons, right? Now, the moon could be a go. There is heaps of helium-3 on the moon. Helium-3 is an isotope of the more common helium-4, having just 1 neutron in the nucleus instead of 2. The lunar soil gets infused with it when it's bombarded by the solar wind from the sun. Perhaps we could mine the moon for helium-3? In fact, that's the premise of the excellent movie titled, funnily enough, Moon, starring Sam Rockwell. Of course, mining the moon is a long way off, so for now, helium is considered a non-renewable resource that we're using up too quickly and will run out of. Now, this is all sounding a little tragic, so how about some good news? In order to get to that, a little bit of tectonic theory. Did you know the African continent is splitting? Not down the middle, but a decent-sized chunk in the upper right is breaking away from the rest of the continent. In terms of tectonic theory, the Somali plate is diverging from the African, also known as Nubian, plate. This is happening in the Afar region, near Ethiopia, at the East African Rift Valley. It's a slow process, but it is happening. The rift is caused by a magma plume in the Earth's mantle. It's thought that this magma plume has been superheating the rocks of the deep crust and driving helium gas out of the rocks. Well, we discovered that helium gas. The particularly pleasing point is that this was the first time we actually found helium on purpose. Armed with knowledge of the region, we went looking for it and found it. All other pockets of helium have been found by accident. So, how much helium was discovered? About 1.5 billion cubic meters. Okay, that's a fair bit. The downside is that the world's annual consumption of helium is about 0.23 billion cubic meters, so really we discovered enough to get us through an extra 6 or 7 years. The upside is that it was found in just one part of the Rift Valley, and it is expected that plenty more will be found. So for now, yay! But I'm still not going to have helium balloons when my munchkins have their birthday parties. And I still vote to head back to the moon real quick. Which, thanks to NASA's Artemis program, is a thing that's actually going to happen in the not-too-distant future. So come on, NASA, take us back to the moon, mine for helium-3, and we can all have grand birthday parties with lots of helium balloons again.
If you like this video, punch that like button. If you want to see more videos, smash that subscribe.